I welcome you all here once again in the lecture series of physics, and today we are going to pick up a new chapter of your syllabus, that's work and energy. And here in this particular lecture of this chapter, we are going to talk in detail about work, the types of work and energy also. So let's get started with the lecture. So here, before starting with the main chapter, before starting with the work in detail, let's try to look around to gather some information about the work. So here, let us suppose if we just take an example and I say there is a book that's lying on the table, and if you just push this book, what you are going to see? You will see that this book will move in the direction of the applied force and the work will be done by you. Let's take up this next example. A fruit falls from a tree. Now this fruit is falling in the downward direction because of the gravitational force that is acting on this fruit. Again, the work will be done by the gravitational force that is acting on this fruit. Now let us take this example. In this example, you can see this man is hardly pushing this wall and he is not able to move the wall despite of the physical exertion that he is experiencing. He is not able to move this wall. Now in this case, what do you think? Work is done or not? Obviously no work is done by the man. Similarly, let us suppose if I say Sana is working really hard for her exams, she is working really hard, but what do you think? Is she doing some work or not? Obviously not. So basically, reading newspapers, studying for exams, discussing questions with the friends, listening to your teacher, in all these things you are not doing any work. Whether these things require the physical or the mental exertion, it doesn't matter how much energy, even right now I am investing while recording this lecture for you, but I am not doing any work at all. So from all these examples that I just have discussed with you, what we have concluded, let's see. So we have seen a force must act on the object in order to do some work. Okay, the object must be displaced. So if you want to have a look again at the examples, you can see in the first example that I have discussed with you, when you push the book, you has applied some force on the book and the book has displaced. So the force was there and the displacement of the book was there and hence work was done. In the case of the fruit that was falling from the tree, the gravitational force was acting on the fruit and the fruit also get displaced, also has covered some distance in the direction of the applied force and hence work was done. In the case of discussing the question paper, in the case of Sana, when I told that she is working hard for her exams, in that case she was not applying any force. There was not the displacement that was included there and hence no work was done. So what are the two important things? The force must be there and there must be the displacement. Even in the case when the person was pushing the wall, there was no displacement and hence the work was zero. So I hope this is quite clear to you that in layman language, anything that acquire whether the physical or the mental work, that is going to be called as hard working. But in physics, you will say the work is done only if there is going to be the force and there is going to be the displacement. Without that, there is no meaning of work in physics. So keep this thing in your mind. Now, what are the factors on which the work done is going to depend? Let's have a look. So the factors on which the amount of work depends, and here we have the first factor, that is the magnitude of force. So if we basically talk about the force, obviously let's take up that again example in which you were pushing the book. If you will just push the book harder, that's gonna fall down from the table. Okay, so the work that will be done by you will be decided by the amount of force that you are applying. Okay, so the magnitude of force matters. So basically the work is directly proportional to the force. Okay, more will be the force, more will be the work done by you. It also depends on the displacement of the body. So basically work done by a given force is directly proportional to the displacement of the body. So more will be the displacement, again more will be the work, keeping the force same. It also depends on the angle between the force and the displacement. Okay, so these two things that you have already seen in the previous board, here I have added one more thing. Yes, this also depends on the angle between the force and the displacement. So here you can see, so here this work is proportional to this cos theta. In other words, this can also be interpreted as F cos theta, which is the component of force in the direction of displacement. Okay. So what are the factors? Let's revise them again. So as I have told you, it depends on the magnitude of the force. So work is directly proportional to the applied force. It depends on the displacement of the body. If there is not going to be any displacement, no work will be done. If there is not going to be any force, no work will be done. Okay. It also depends on the angle between the force and the displacement. That is how I just have discussed with you, that it actually depends on the component of force in the direction of the displacement, that is F cos theta. So what is the basic formula for the work done? I am just going to write it over there. So work is basically F S cos theta, where this F is the applied force, S is the displacement, and theta here is the angle between the force and the displacement. Okay, or even you can call this F cos theta to be the component of the force in the direction of the displacement. So I hope whatsoever I have taught you so far in this segment of the lecture is quite clear to you. Now let's move on to the next segment and try to discuss in detail about this work.